My name is Gabriel, and today I'm going to go over lab number 2, charge tapes revisited. The objective of this lab was to compare a point charge model done in experiment 1 to a line charge computational model. As an overview, the tape charge point model yielded a charge of 8.18 10 to the negative 9 coulombs, and the line model gave 1.9 10 to the negative 8 coulombs. The system analyzed was tape B, and the surroundings were tape A and earth, as shown in the picture to the right. The fundamental principles applied were Newton's second law, Newton's third law, gravitational force, electric force calculation based on electric field, and the superposition principle. Some general assumptions used were that air resistance was considered negligible. Each U-tape was separated in sections of equal charge. Charged tapes have equal charges, and some loss of charge could happen due to tape handling. As an overview of Lab 1 results, this picture shows the forces. The blue force is gravitational force, and the green one is electric force. The magnitude of charge was 8.10 10 to the negative 9. In Lab 2, we decided to divide that tape and instead of a point charge, consider it to be a line charge. This code on the left shows the function defined to calculate the electric field based on a particle charge and the observation location. Towards the right is the function we use to define the line charge, which is basically takes a tape, divides it into n sections, and calculates the overall charge divided by n. The second portion of the code was to calculate the net electric field, which is where the principle of superposition was used. Basically, for each of the tiny pieces that was divided by the line charge function, the electric field was calculated. And then by superposition, the sum of those electric fields is defined as the net electric field. As an overview of Lab 2 results, I basically trialed and errored different Q values up until the magnitude of electric force was almost the same as the gravitational force. The value I obtained was 1.9 10 to the negative 8. And this value, it is important to stress that is 1 order of magnitude higher than the point charge model. Going forward with the final discussion, what if you had modeled each of your tapes as a single point, like in the previous lab? Compare the values you got. So basically, if the tapes were assumed to be as a single point, the charge in them would be much less than the ones obtained in the line model. As you can see, they differ by almost 1 order of magnitude, which is a pretty significant difference. And a second question was, why do these estimates differ? Which value is more likely to be closer to the real value and why? The values are different because they use different models and levels of precision. For example, the point model assumes the charge is based on one single point. The line model divides the tape into various sections of equal charges and is likely, because it divides in very tiny sections, to be more accurate to a real-life representation. If further precision is needed, the tape can be divided into even more and more number of points.